Welcome to session 5 of unit 4, cumulative distribution function. Remember we're doing cumulative distribution function of a continuous random variable in session 4. Now we are doing continuous random variable, cumulative one, in session 5. So by the end of this session, we should be able to construct cumulative distribution function for continuous random variable, state and explain some basic properties, calculate probabilities from continuous random variable, obtain probability density function from a continuous distribution function. Definition. The cumulative distribution function denoted by f of x of a continuous random variable x with PDF, that is probability density function f of x, is given by, so we are given as f of x is equal to probability of x less than small x, and this is we integrating from negative infinity to x of f of t over dt, and conversely this should be equal to 1 minus integrating from x to positive infinity over the same function f of t over dt, where x takes values from negative infinity to positive infinity. Maybe let's look at an example. The PDF of a continuous random variable x is given by f of x equal to 0 where x is less than 0, x over 2 where x lies between 0 and 2, and then 0 also where x is greater than 0. So either side, when x is less than 0 or greater than 0, the probabilities are 0. When x is between 0 and 2, that is to have x over 2. We have to find the CDF, cumulative distribution function of x. Solution. So remember, if x is less than 0, it means that we are integrating from negative infinity to 0. And integrating that, the function given here is what? 0. So integrating 0, we will still have what? The whole thing giving us what? 0. The next one, that's integrating from 0 to 2. 0 to 2, we talk about cumulative. So we start from negative infinity to 0, and from 0 to 2, f of t dt. And then from 2 to positive infinity. You get it? Now, the extremes will always give us what? 0. Or the endpoints. But from 0 to 2 will give us a function. So integrating from 0 to x. From 0 to x, we have, and we are, remember, we are integrating t. So we represent the x with t. So now the function will now be, instead of x squared over 4 dx, we now have x squared, or sorry, t squared over 4 dt. And substituting in the value, we have x squared. 0 to x, we have x squared over 4. For x greater than 2, of course, please, sorry, remember the function we are dealing with is x over 2. X over 2, sorry, x over 2. Yes, so we integrating this will give us, and now changing x over 2 to what? T over 2. Integrating t over 2 should give us t squared over 4. And putting in the values from 0 to x will now give us x squared over 4. I think that is the right thing. That was an error, sorry. Yeah. So that is what we should have. Now if x is greater than 2, the function will be equal to 0. Right. So what it means that when we sum up everything from beginning to the end, from negative infinity to positive infinity, with the interval given, it should be equal to 1. It should be equal to 1. Calculating probability from a continuous distribution function. So given the CDF, that's the continuous distribution function for random variable x. Probability for various interval of x can be calculated from them. So let's look at example 2. Example 2 says let the PDF of x be given by f of x equal to 1 over 8 plus 3 over 8x on the interval 0 to 2, 0 or elsewhere. We're to find the CDF of x, the probability of x taking values from 1 to 5, and the probability of x greater than 1. Solution. For any number x between 0 and 2, we should have the function here as 0 to x, and we integrating the function with respect to what? T, by changing the values of x to t and giving x the function as the limit. So the right integration will give us 1 over 8x plus 3 over 16x squared. And that gives us this function. When we have the extreme, as the function is less than 0, we have 0 being the answer. The function is from 0 to 2, we have the function as x over 8 plus 3 over 8x squared. And the function as x greater than 2, we have it being 1.